Okay, GeoTrig here. We're going to do lesson 20 of this group of trig functions. This is on the two special triangles. As you can see that you guys have, I printed out all of the outlines for these. The packet is very hefty, so don't lose it, please. And it's going to be a little chunky on here because of the spacing and trying to space it out better. But, guys, we've used sine, cosine, and tangent before. That's the trig identities. When can we use them? What kind of things can we use sine, cosine, and tangent on?
Right triangles.
Right triangles. So we're only allowed to use them right triangles. So we can only use them on right triangles. And in the past, specifically lesson 14, we were able to use our calculators. I've asked you, what is the sine of 40? What is the cosine of 84? Right? We were able to do that. Today, I'm going to start teaching you ways to do some of this trig work without a calculator. What we started recognize, because we started touching upon a little bit of the all students take calculus, kind of introduced it a little bit, is the fact that these functions are periodic, which means they repeat themselves over and over and over and over again. So, they go up to 1, down to -1, back up to 1, down to -1, and repeat back and forth. But to get from -1 to 1 and back down to -1 and then back up to 1, you guys should recognize that you would have to pass through the same values over and over and over again. So, what we start to hopefully realize is that sine of 30, which is 1/2, 1/2 comes up a lot. It comes up at 1/2, 30, it comes up at 150, it'll actually show up at 210 for sine, but it won't be positive, it'll be negative. So there's a couple of different places here that we're going to see the same values over and over, just positive or negative. The angles that we're going to specifically talk about are 30s, 45s, 60s. We'll even talk about 90s at some point down the line. But those are the ones that we're going to focus on today. These all are for the reference triangle. You're able to make very specific triangles that help us identify the ratios, the sides. I'm hoping that people understand that I have 45, 45, and 90 adds up to 180. And here's the cool thing. When I draw this reference triangle or the next one that's on your page, which is a 30, 60, 90, I will draw them the very specific way. I pretty much draw them with the same triangle. Pretty universal, as in I start at the top, draw down to 90, over and back up. I formed that triangle. 45 is the top left, 90 is at the bottom left, and to the bottom right is 45. The cool thing about it is that I can now put 1, 1 for each one of the legs because that forms an isosceles triangle. Both the legs are the same. And 1 squared plus 1 squared is 2. And the square root of that is square root of 2. So therefore, 1, 1 square root of 2 is the reference triangle. And they have a special ratio. If you guys could imagine, I could take this thing and I could make it change in size. As in I can make it this big. Right? But guess what? The sides are still 1, 1 square root of 2. I could shrink it down to the point where it's that big. It's still 1, 1 square root of 2. So I'm going to bring this back up to here so we can talk about this. This is where I'm trying to get to with that other triangle. This is still that 45, 45, 90 triangle. They can be similar but different sizes. And the only thing difference, if you remember back to similar triangles, is that these two triangles would have to have a common ratio. Well, guess what? On the bottom of this one, it says that this length is not 1, it's x. So what should this one be? It should also be x. And what about the hypotenuse?
X square root of x.
X square root of 2. Because, if you think about this, if I were to take the bottom of this triangle and multiply it by 5, what do I have to do to the rest of them? Multiply it by 5. Multiply it by 5. I have to multiply every piece by 5. Because what you do to one of the pieces, you have to do it to all three to keep it a 45, 45, 90. So that's the side ratios that we're looking for. It's x, x, x square root 2. That would give us a ratio. As soon as you knew what the value of x was, you could plug it into all three. You would know all three sides. If you recognize it was a 1, 1 square root of 2 ratio, which is what it is, you know you're dealing with a 45, 45, 90 triangle. This comes up on the ACT. The ACT likes to do things like throw math triangles at you that you don't have to use a calculator. You don't have to use much thinking. It just automatically be there if you recognize the pattern. The other pattern is this one. It's a 30, 60, 90 triangle. A 30, 60, 90 triangle, again, okay, I messed up on this one. Fill it in for me. Put right triangles in there. These are 30, 60, 90s. I will always put the 30 degrees at the top left. 90 is straight down on the bottom left. And to the right bottom should be my 60. Bless you. If you do that, you will end up with a 30, 60, 90 triangle that you can walk counterclockwise. I start here, 1, 2, 3. The bigger number gets the square root. Actually, go back once. 1, 1, 2. 2 is the bigger number. It got the square root. So, the bigger number gets the square root. So just like before, if this bottom is x, what's the hypotenuse? 2x. What is the left side? X times square root of 3. So the ratio up here is x, 2x, x square root 3. What if I told you that the position here was 10? What's x? 5. So the bottom one has to be 5. What would be the left side? If this was 10, x has to be 5, so this becomes a 5, and then it becomes 5 square root of 3. Okay? Questions? Next, guys, I want to solve for x and y. So, you look at that triangle, the top one. What is it?
A right triangle.
It's a right triangle. What kind? It's a 30, 60, 90. You know this because there's a 90, there's a 30. It's missing the 60. So we have a 30, 60, 90 triangle. Here's the thing. It is not laying the way I want it to. It's not in the right orientation. So I'm going to, off to the side, make my own 30, 60, 90 triangle using my method, which puts 30 up top, 60 out to the right, and then I can put my own numbers on. 1, 2, 3, and square root. Okay? I did this because I'm not going to try to remember all the different ways that this triangle could be written or drawn. I'm going to memorize once. Because watch this. Now wait, let's make a small connection here. 30 is the smallest angle. It is opposite the
1.
which is the smallest side. 90 is the biggest angle, and it's opposite the 2, which is bigger than all three. Square root of 3 is like 1.7 something. Okay, now watch. This is the reason why I make my own drawing. Is that now, can't I just take this? Make it a little bit larger, and I just made a copy, didn't I? You now have the exact same triangle. Could you tell me x?
2.
Oh, wait. Is x 1?
4.
Oh, ho, ho, ho. Why do you say 4? Yeah, 1 second. Guys, remember, this really possibly should have x attached to it, x attached to it, and x attached to it because it's a ratio of some multiple. Where's the only number on the left side? It's 4 square root of 3. What does it say it's here? It's x square root of 3. That means x has to equal
4.
So x equals 4. Now, got to be careful. It may not line up with this idea that this x and this x are the same. So you got to be careful with that. But notice that if that's true, then this x is 4 and 2 times 4 is 8, right? So that means this has to be 8 and x has to be 4. So y is 8, x is 4. Number 2, what kind of triangle is that?
45, 45.
It's the 45, 45, 90, but how can I actually say that?
Because
The dashes, the tick marks, okay? But that just means they're the same length. What kind of triangle is that?
right triangle.
It's a right triangle. More specifically, it's a isosceles. And by definition of isosceles, two angles the same, and then the angles opposite them are the same. Okay, so we know it's an isosceles triangle. It's a right isosceles triangle. And therefore, if it's a right triangle, that's 90 degrees. What's left for the other two angles? It's a 90 left. Split equally between two angles means they're both 45. So I go back to the drawing board. I make my 45, 45, 90 triangle. My two legs are 1, 1. Hypotenuse is square root of 2. You will have to know that. You'll have to memorize that. More specifically, I'm going to use the ratios with variables x, 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 right? Because that way I can find out what x is. Are they sitting the exact same way? No. So, you can do this in your head. I have the ability because of the technology I have in my hands. But, could you not do this? And look at that. Now it's upside down for the writing. But, could you tell me the lengths of the two sides in this triangle based off of the hypotenuse? It's the only thing they have in common, isn't it? Whoops. I moved that one really far away. Oh, now I moved it back. So, 9 square root 6 equals 2, not 2, but x square root 2. You guys agree with that? Because of this hypotenuse is equal to that hypotenuse. That means I can solve for x. And technically, x is what I want because I want to know the lengths of each side. Divide by
Square root of 2.
square root of 2. What happens when I take a square root times a square root? What can you do with the numbers? Square root of a number times another square root of a number. Take the numbers inside and multiply them. If you have a square root divided by a square root, what can you do then? Take the numbers and divide them inside. Is 9 inside or outside?
Outside.
It's outside, so it does not get affected. What's the square root of 6 divided by square root of 2? And there's x. X happens to also be the length of each one of these sides. Okay, I want you guys to solve for x and y. Be very careful because these variables are in opposite positions of your formula. Try it on your own. Okay guys, here we go. This is a 30, 60, 90. And so, here we go. Draw my triangle. 30, 60, 90, 1, 2, 3 with the square root. Hopefully everybody's starting to. I know it just maybe be your first day today, but I'm hoping that by saying you do this every single time, it starts to become second nature.
Wait.
That is my reference triangle. I'm not done.
Well, wait, why did you put those numbers inside?
Because those are the numbers or the ratios for the reference triangle of a 30, 60, 90. Now, I'm going to go and put x by each one, because each one of these is just going to be a multiple. So I should be able to find these numbers, x, y, and 17, as a multiple of those ratios. Now, I'm not going to spin this one around. So let's take a look here. Where's the only number in this triangle? 17 for one of its sides. That is the hypotenuse. That means 17 has to equal the hypotenuse over here. 2x. So 17 equals 2x. X equals 17 over 2, which equals 8.5. Now, 8.5 is not a bad number in itself. You may still want to use 17 over 2. Okay? Now, wait a minute. That means I could put this 8.5 or 17 over 2 back in for these two ratios, which represent x and y. Granted, that x is not the same x as in the problem. What's opposite 30 here?
Y.
Should be y. What's opposite 30 here? X. The x and the y are not the same. One is a variable, and one stands for that position in the formula. So I'm going to change colors so that we can see this a little bit better. But we should then say that this is y, and this is what we're going to call x. All I have to do then is say, hey, y is 8.5 because y is equal to x. But x up here is equal to 8.5 times square root of 3. X equals 8.5 square root 3. Well, here's my issue. I'm not going to leave decimals and square roots next to each other. That just doesn't make sense to me. Doesn't look very nice. So I'll just put it as 17 over 2 square root 3. And you just found both. And the no calculators. Now, you guys, to do these, we have to kind of go back to what we did in lesson 14. We can use SOHCAHTOA. So let's write SOHCAHTOA down. That's big. It's SOHCAHTOA. You don't have to draw the actual angle of 30 degrees, 45 degrees, 60 degrees, so forth, you can use just reference triangles. So let's talk about putting those on here, because it's a new page. So that's 45, 45, 1, 1, square root 2. That's a bad triangle. 30, 60, 90, 1, 2, 3, square root. Okay? Those two triangles, I just drew them real quick, SOHCAHTOA there, so that if I'm at 45, I know it's opposite, what's adjacent, what's hypotenuse, so forth. So, I highly suggest that you guys start getting to this use of this idea that you should possibly graph or plot at an angle. So if I say tangent of 30, 30 degrees is somewhere about there. Would you guys agree that that could be 30 degrees?
Sure.
That's a really small 30 in there, but 30's at the origin and the x-axis. There. That's 30. But wait a minute. If I went straight down to the x-axis, doesn't that form a right triangle?
No.
And we've done this before. When we converted from polar to rectangular and back and forth. If that's 30, what's the other angle? 60. Wait a minute. That's a 30, 60, 90 triangle? Could I put the sides on?
Yeah.
Opposite 30 is 1. The hypotenuse is 2. And the adjacent would be square root of 3. Wait a minute. Can I take the tangent of that 30 now? Tangent is opposite over hypotenuse. What's opposite of 30? 1. What's adjacent?
2.
Square root of 3. So it ends up being 1 over square root of 3. Ta-da! Now, do we leave things with square roots in the basement?
No.
No. We fix it. We multiply by square root of 3 over square root of 3, so it becomes square root of 3 over
3.
square root of 3 over 3. That's what you have to do. Number 5, the last one we're going to do. 7 sine of 45. Is the 7 inside or outside? The 7's outside. It's attached to the function of sine. So when I go to evaluate it, I don't care about it. I leave it out front. Whatever I find sine 45 to be, I'm just going to multiply it by 7. Oh, that's a 45 degree angle. Let's graph that. 45, 90, 45. Nothing about this looks pretty, right? I'm not taking my time making these beautiful looking triangles. I'm using it as a reference, and if I use it as a reference, it doesn't have to be perfect. But I do know that it should be 45, which is 1, 1, square root of 2. Do you have enough information to tell me the sine of 45?
Yes.
Now, the question might be, which 45 am I supposed to use? Use the one at the origin. So here's 45. What's opposite?
1.
And hypotenuse.
Square root of 2.
So it becomes 1 over square root of 2. Hey, again, we don't like 1 over square root of 2, so we change it to?
Square root of 2 over 2.
So it ends up being 7 square root of 2 all over 2. 7 times the square root of 2 all over 2. Guys, if you guys want to do some little extra practice, this becomes 2 square root 3, and this one is 1, so it would be 5 square root 5, I think. No, 2. 2 square root 5? Off the top of my head. I want to say it's 2 square root 5. Your homework is right here, lesson 20, page 148, 1, 9 through 11, and 24. Have a great day.